Welcome to the third in this series of videos where I'm looking at this Sanyo VTC-MH5 NTSC HiFi video recorder. Where I left it at the end of the last video was the machine is basically now working. It records, it plays back, all the tape transfer controls are working fine, but there's just a couple of problems with it still. Firstly, when you try and turn it off to standby, it doesn't seem to completely go off. So a lot of the lights stay on the front panel. The power light doesn't go out. The beta hi-fi light stays on, and it mutes the audio in E2E mode, but it still passes video through in E2E, and the tuner stays on, but a lot of it still stays on. I don't think that's quite right. Also, I noticed the power supply, even if the machine isn't in use, seems to get extremely hot very quickly. If you just plug the machine in, literally within about 5 minutes, this heatsink over here is much too hot to keep your hand on. So again, it could be right, but I just don't think they would have designed the power supply to run that hot. Now, I was thinking about this, and I commented in a previous video on how the cassette loading and the lacing motors seem to run very fast, a lot faster than the other machines with this similar deck. Oh, that was quick. Let's try eject. Oh, fast, but it worked. Right, let's go for play. Well, that's nice and quick. Stop. That's very quick, isn't it? So I'm wondering if that is actually correct behaviour, because if one of the voltage lines from the power supply is too high, that might be overrunning those motors and making them run very fast, and that could be causing other problems. So I'm wondering if there's a fault with the power supply on this machine. The problem I've got with that is I can't find any service information for this machine specifically, or the VTC-M5, which is basically the PAL version of this machine, I think. The only power supply information I can find is this block diagram from the VTC-M10 manual, which is a little bit different. And of course, this refers out to the VTC 6500 manual for the proper schematics of the power supply, and of course I can't find the VTC 6500 manual, so all I've got to go on is this block diagram. But it does give me a few output voltages here, and of course I've got the data sheet for the main voltage regulator, which is an STK7217. So one thing I can do is check the output voltages on that voltage regulator, but to do that I'm going to have to get the power supply out of the machine, I think, because the voltage regulator is down in here, and I can't, the PCB is here, and the pins of the voltage regulator are blocked by this heatsink, so I can't get into it from this side. So what I'm going to try and do is remove the power supply unit from the machine, see if I can get access to the output pins of the voltage regulator and check the output voltages. Other more minor issues, I've mentioned these two. The bottom panel screws are missing, they need to be replaced, and also I need to try and refit the front flap. This one, the bottom panel screws, I can do fairly easily, so let's have a go at that. Okay, I've taken an example screw from the VTC-M20 machine, which is, I've checked that's the same screw for the bottom of the VTC-MH5, and went off to my local hardware shop, but the closest screw I could find were these, which are the right thread, but they're quite significantly longer. I mean, they're more than twice as long as the original screws, but I've had a look in here at each of the 4 screw positions, and in all cases there's absolutely nothing anywhere near the underneath of these screws. There's nothing that these longer screws are going to interfere with. I was just going to cut these down to size, but having looked at the screw positions here, I think I can just put the long screws in, because they're just not going to interfere with anything at all. So I'll go ahead and do that. So, that's the bottom panel reattached properly. I've got 4 screws holding the transformer in here. Oh, there's another screw here. One of the base screws is holding it in. So maybe I shouldn't have refitted those base screws. So I now have the power supply out, although obviously it's been very hot here. Nothing's immediately sticking out as an obvious failed component on here. These 4 connectors along the top edge here I'm not too worried about because they go off to various things in the machine that I don't care about. According to the block diagram, CN5102 goes off to the timer circuit. I don't really care about that. CN5103 here goes off to the channel select control circuit. Again, I don't really care about that. CN5104 here goes to the RF converter. Now, according to the block diagram, only pins 1 and 3 are actually used on that connector, but clearly 4 and 5 on here go off to other bits of circuitry on here, so 4 and 5 are clearly used on this one. And CN5101, this little 2-pin connector on the end, isn't actually shown on the block diagram at all, so there are differences between this power supply and what's shown on the block diagram. But either way, I'm not too bothered about these 4 along here. The one I'm mainly interested in is this white one here, which goes off to the main system control board. But again, there's differences here, because in the block diagram that's shown as having at least 12 pins, only 9 of which are used, but this is just a 9-pin connector, so there are going to be differences. So if you look at CN5201, which is that white one I just showed in the power supply, the pins are numbered from 1 to 12, but there's only 9 used. Now, pin 9 on here is labelled as power up, as an incoming signal from the SY1 board, so this is obviously the pin that signals to the main voltage regulator to turn on or off. And pin 9 on the connector actually goes to pin 9 on the voltage regulator IC. Now, if we look at the data sheet for the voltage regulator, we see that pin 9 is labelled as cut-off. And apparently, look at the other page, it says it's a high activated output cut-off function. So, hopefully, if you take pin 9 high, it cuts the regulator off. So if pin 9 floats low, then the regulator should be on. So hopefully I can just plug the machine into the mains and the power supply will come up if that pin 9 floats low. Otherwise I might have to pull it down. But the first thing I want to do, I think, is just plug it in, power it up, and see if it still gets extremely hot even when it's not connected to the rest of the circuit. That would then indicate there's a problem internal to the power supply, which I'm kind of hoping is going to be the case. So let's give that a try first. So I'll put that like that. I'll just prop that up with a videotape just to keep it there, just so I can get at the heatsink there to feel if it's getting hot. Plug in and power up. Nothing's exploded, which is a good sign, so I'll just leave that for about 5 minutes and see if the heatsinks are getting hot. Okay, annoyingly I wasn't recording, but we've just had major fireworks here. Something went bang and there was a huge puff of smoke and it made a puddle of brown liquid on the table underneath the power supply here. So one of these capacitors has just gone pop. I can't believe I wasn't recording when that happened. That would have been really good to capture that, but unfortunately I didn't. So we've clearly now got a capacitor failure here, so I think I may as well just get this little board here off, just change all the capacitors on it. Can't believe I wasn't videoing when that happened. That's really annoying. First thing I'm going to do, I think, is give this a good wash under the tap. Okay, I've got that capacitor off the board now, the one that exploded. Now, I've been having a bit more of a think about this, and I think that capacitor failure was a symptom of the problem, because that's in conjunction with that inductor there is just a filter on the 12 volt output from the voltage regulator. And that capacitor is effectively just straight across the 12 volt output of that voltage regulator. So I'm now wondering, I'm going back to my original theory, that the output voltage from that voltage regulator is too high, and I think maybe testing the power supply off load out of the machine allowed that voltage to go up even higher, and that's caused the failure of this capacitor, which is only rated at 16 volts. So what I'm going to try and do is find a spare regulator. I've got several other video recorders which have similar regulators in, but they're 7216s, which are essentially exactly the same but slightly lower current rating than the 7217. So I think if I put one of those in and give it a try, that should be alright for a short time. Obviously I wouldn't want to leave it like that, but just to prove that the voltage regulator is at fault, or maybe isn't at fault, I think that's what I'm going to do. So I shall raid a 7216 out of another video recorder and fit that, and I'll fit a replacement capacitor in there as well. Okay, I've removed the suspected bad STK7217 voltage regulator from the machine. I've just labelled it as suspect bad just so I don't accidentally refit the bad one back in the power supply. And I've raided this VTC-5000 for its STK. It's a 7216 actually in here, so as I say, that's a slightly lower rated in terms of current regulator. I've fitted that in the power supply, and I've also replaced that capacitor that exploded. That one I've put in is actually a higher voltage rating, it's 25 volt rated one, that one. I gave the power supply a quick try out on the bench, and there was no voltage at all coming out of the regulator. I think that's probably just because I hadn't brought up that power up pin. So I thought, well, by the time I've faffed about trying to get the voltage regulator to initialise out of the machine, I might as well just mount the power supply back in the machine. So rather optimistically, I've mounted it back in the machine and reconnected all the output cables, and it's time to give it a try. VTC is giving out 100.3 volts, which is perfect. So here we go, moment of truth. Looking promising. And it's powered up. Does it power down properly? Yes, it does. Yeah, powered up. And it's powered down properly. Brilliant. So, I'll just leave that on for a few minutes and see how hot the power supply gets. Okay, that's been on for a few minutes now, and this is barely even warm. In fact, I would say it's cool. That little transistor there's getting quite hot, but I think that's normal. Not worryingly hot, that's okay. Yeah, I think that's fine. So, shall we try loading a tape and see if the motors run at a more sensible speed? I'll load my empty shell first. That sounded much better, didn't it? Yes, that's much more sensible motor speed. If anything, possibly even a shade too slow. Right, let's try lacing. Yes. Much better. Yes, those motors are running at a much more sensible speed, aren't they? I think we've solved the problem there. So what I'll do now is I'll try and see if I can get hold of an STK7217 to put in here instead. But for the time being, I'll just leave that one in there. That should be alright for a short time, just to have a little bit of a play with the machine. And it goes off properly. Excellent. Right. Let's get it hooked up to a TV and give it a proper try. Right, so hooked up to a TV, I've got the AV outputs from the video recorder going directly to the AV inputs of the TV. I'll try my test tape first of all, so just to make sure the thing works. So again, don't use this to judge the quality, just want to make sure the machine actually works. Loaded nicely, and play. Looking good. Have stereo lit up. Beta Hi-Fi lit up.
Sound has a look all its own.
And it's playing the Hi-Fi track.
On a home video cassette recorder.
No, we lost audio there, but I've just put that down to the tape being terrible. So now we've seen it works, we can try a decent tape. As luck would have it, I've literally just today received this test tape, which should hopefully have some NTSC video with hi-fi sound on it. Big thanks to Howard of AVtransfers UK. I'll put a link to his channel in the description for his help in getting hold of this tape. It's genuinely the first time I've looked at this tape, so I don't even know what's on it yet, so let's give it a try. I think we need a bit of tracking adjustment here. There we go. Success! The only other thing I briefly wanted to look at on this machine was the built-in FM radio receiver. Now, I've got just a bit of wire connected up to the aerial connector at the back, and I've got some powered speakers connected to the headphone output so I can hear it. So if we turn it on, it's actually already in FM mode, it's not tuned into anything. Now, the tuning controls are all up here. We've got the tuning controls for both the TV and the radio receiver here. Now, to look at this FM dial, you'd think that was just a manual FM tuner, wouldn't you? But no, it isn't. You switch it to tuning mode, and now we can manually tune the FM tuner in and find a station. But not stop on one that's playing music. Or silence. So there we go. Now I can choose which preset number I want to store that in with these two buttons here. Then I can store it. And now that's stored in that preset position, so I can tune away to different channels and tune back to that preset, and it's remembered that setting. So each time I go into tuning, I can use this, what appears to be a manual tuning dial, to tune in a different station and store that in a different preset location, which is quite interesting. Of course, the idea behind all that is you're supposed to store a TV channel along with a radio channel, or radio frequency I should say, and then the machine will record the picture from the TV channel and the sound from the FM radio channel. So you'd get what's called simulcast recording. But I just thought the way it operates is rather unusual, and you've got this, what appears to be a manual tuning dial, but actually isn't. And it actually sounds pretty good. It's quite a sensitive receiver, just with a piece of old wire stuck out the back. I don't know what this rubbish is I'm listening to, but should we see if we can find something a bit more interesting?
Absolutely, and I think the fundamental starting place.
That's quite a weak station.
Understanding, when you consider how profound the implications are, that this isn't a job for a single government or.
Yes, unfortunately, being a Japanese receiver, it's only tunable between 76 and 90 megahertz, which is not ideal. But anyway, just thought I'd show you that because, oh, let's turn that back to preset. Because the way that works is, I thought that was sort of quirky. So what have I got left to do on this machine now? Well, I've got to change that voltage regulator for one of the correct rating. And then I think the only other thing I've got to try and do is reattach this front flap. which I still don't really know how to do. If anyone knows how to attach the front flap on these machines, please let me know in the comments and tell me how to do it, because I think I'm going to struggle with that. But anyway, I think that's a nice, fully working Sanyo VTC-MH5 Beta Hi-Fi video recorder. Thanks very much for watching.